Hello, and welcome to the fourth film, I think it is, fourth film about moles in Year 11. Getting to the end of the series, getting towards the end of the term and Christmas actually, but anyway, this is the fourth one, and it's about how we interconvert mass and moles. Okay, why are we doing this? Because often you don't want to count atoms in moles because you can't really count them because they're a bit small. But if you can weigh out a substance and have an idea of how much of it there is in moles, then that's a useful thing to be able to do. Okay, so by the end of this film, you'll hopefully know the symbols for mass, for moles, and for molar mass, and you'll be able to practice interconverting those things. Okay, so let's have a look. What symbol do we give the number of moles? Well, that is given the symbol n, little n. Should remember this from one of the first couple of films about Avogadro's number and moles. Okay, so that's not new. Symbol for number of moles is little n. The symbol for mass is little m. Okay, so lowercase m stands for mass, and we're usually going to measure this in grams. Okay, but sometimes you might be given it in kilograms, sometimes you might be given it in tons. Okay, sometimes you might be able to, you might even be given it in milligrams. Okay. It's important that you can understand how to convert these things into grams because we want masses in grams if we're going to be able to use molar masses for our calculations, which we need to be able to do. So just remember that there's 1,000 grams in a kilogram, there's 1,000 kilograms in a ton, and that there's 1,000 milligrams in a gram, so this is 1/1000th of a gram. Okay, so make sure you can convert these things. It's really important to do. But anyway, mass, given the symbol m, usually measured in grams. Okay, now as for molar mass, now we've found out in the previous film how to calculate this, and we were told it's the mass of 1 mole of a substance. Okay, it's given the symbol capital M as opposed to lowercase m for the mass. Okay, but remember we can always find the molar mass from information in the periodic table. Okay, so if we know the formula of a substance, so we need a formula if we're going to find the molar mass of something. Okay, need a formula, and then we can add up all the atomic masses like we did in the previous film. Okay, right, let's see if we can figure out some relationships here like we did before. Okay, now if I had 2 moles of something, right, how do I find out how much it weighs? Well, if you know the molar mass of something, you know how much 1 mole of it weighs. So if I said to you something weighed 10 grams per mole, and I told you you had 2 moles of it, you'd probably be able to tell me it would weigh 20 grams. What have you done there? Well, you've tried to find out the mass. Okay? And you said to me, well, I've just doubled it. So I took this number 2 and I multiplied it by the mass of 1 mole that you told me. So you've taken the number of moles and multiplied it by the mass of 1 mole. Okay? That's how you found the mass. It's just common sense, really. Or you could just remember that formula. Don't have to figure it out, you can just remember that formula. You can then rearrange this formula and find what the formula for the number of moles is. And that's little m over big M. You'll use that formula probably 1,000 times before you finish year 12. Okay, maybe more. Okay, if you like triangles, you can arrange these things in a triangle and say that n equals little m over big M. And then you can just cover up whichever one you're interested in, and the triangle tells you what's left. So little m equals n times m. Big M equals little m over n. Sometimes you'll need to use that one, okay? If someone tells you the mass of substance that you've got and the number of moles that is, then you could divide the mass by the number of moles and that would tell you big M. That might even allow you to figure out what the formula of a mysterious substance is. Okay, so not so often used, that one, but it does come in handy, so make sure you can use it. Okay, anyway, coming up are some examples of things that we could do here. So if we're converting moles to mass, the question might look like, what is the mass of, or how much does such and such number of moles weigh? So let's say I had, I don't know, 0.2 moles of sodium chloride. Okay, what is the mass of? We are saying m equals n times big M. Okay, that's one of those 3 formulas we learned just now. Okay, so n is 0.2. What's big M? Well, I've got to find that out from the periodic table. It's 22.99, which is sodium, plus 35.45 for chlorine. Add those 2 things together, multiply by 0.2, and I've got the mass of this amount of substance. how much does, let's say, 105 moles of, I don't know, water weigh? Okay? How do we do that? Well, again, it's the mass. How much does it weigh? We're finding a mass equals the number of moles, 105, times the molar mass of water. Well, that's H2O. So 2 times 1.008, because that's hydrogen. All right? And add to that oxygen. There's one of them here, so I've just got 116. Add those things together, multiply by 105, and you know how much 105 moles of water weighs. Okay. All that's left really in this film, let me just check that actually. Yes, that was all that was left. Let me just come back to that previous slide. Okay. All that's left is to find out how we convert mass to moles. So now I'm told a mass and I'm being asked to find how many moles there are. How many moles are there? So this is how the questions might look. How many moles are there in 50 grams, let's say? 50 grams of, I don't know, what should we have? Potassium manganate. KMNO4. Okay. How many moles? We're being asked to find little n. That's the number of moles, and that is little m over big M. It's that one that I told you you'd use again and again and again and again. Okay. 50 grams, so the mass is 50. Find out what KMNO4 is. I think, what's that? 39.1. 39.1 manganese. I've got absolutely no idea. 54.94 for manganese, and then we've got 16 times 4. All right, add those things up and then divide 50 by the sum, and you've got how many moles of there are in 50 grams of potassium manganate. If, and this is going to be really useful in a film in a couple of films time, if let's say 0.25 grams of something are reacted with something else in a question, then you probably need to look at that and go, oh, I could find the number of moles here, because the number of moles is the mass over the molar mass. Okay, so let's say chlorine. Chlorine has the formula Cl2. Remember, it's a diatomic one. So 0.25 moles, 0.25 grams. So mass is 0.25 grams. The molar mass, well, that's 2 times 35.45. So figure out what 2 times 35.45 is, divide 0.25 by it, and you've got the number of moles of chlorine that you've got here. Okay, so that is how we use little n, little m, and big M to calculate masses if we're told numbers of moles, or numbers of moles if we're told masses. And these things are going to be really important in the kind of, I suppose, one of the tougher things that we do in the first term in Year 11 in reacting mass calculations. But before you watch that film, can I suggest you watch the one about moles in balanced equations?